The topic for today is multiple correlation. Studies made on relationship between several variables simultaneously is termed as multiple correlation. As an example, one wished to study the relationship between yield and other causing factors such as soil fertility, chemical manures, and rainfall. The role of multiple correlation comes to help. In multiple correlation, we study three or more variables at a time. I repeat, in multiple correlation, we study three or more variables at a time. Whereas in case of partial correlation, we study relationship of two variables. By making the other factors constant. In multiple correlation, the effect of all the independent factors on a dependent factor is studied. A dependent variable is indicated by capital X1 and the independent variables by X2, X3, X4. So I repeat, the independent variables are denoted by x2, x3, x4 dot dot dot, and the dependent is denoted by x1. The coefficient of multiple linear correlation is represented by R. The coefficient of multiple linear correlation is represented by R, and the necessary subscripts are added to it. Let there be three variables x1, x2, x3, where x1 is the dependent and the other two are independent. R 1.23 is equal to multiple correlation coefficient with x1 as dependent variable and x2 and x3 as independent variable. I repeat, R123 is multiple correlation coefficient with x1 as dependent and x2, x3 as independent. Similarly, R2.13 multiple correlation coefficient with x2 as dependent variable and x1 and x3 as independent variables, and R3.12 multiple correlation coefficient with x3 as dependent variable and x1 and x2 as independent variables. Now let's move on to the calculation of multiple correlation coefficient. The formula for the calculation of multiple correlation coefficient are as follows. R1.23 is equal to root under R12 square plus R13 square minus 2 R12 R13 R23 divided by 1 minus R square 23. Similarly, R 2.13 is equal to root under R 21 square plus R 23 square minus 2 R 12 R 13 R 23 divided by 1 minus R 13 square, and R 3.12 is equal to root under R 31 square plus R 32 square minus 2 R12 R13 R23 divided by 1 minus R12 square. Let me give you a few remarks. Number 1. Multiple correlation coefficient is a non-negative coefficient. I repeat, multiple correlation coefficient is a non-negative coefficient. Its value ranges from 0 to 1. It cannot assume a minus value. Number 2, if R1.23 is equal to 0, R12 will be equal to 0 and 13 will be equal to 0 respectively. Number 3, if R1.23 is greater than equal to R12 and R1.23 will be greater than equal to R13. Number 4, R1.23 is equal to R1.32. The position of the subscript to the right of the dot does not make a difference. Number 5, by squaring R.13, we get the coefficient of multiple determination. So, coefficient of multiple determination is equal to R1.23 square. If there are 3 independent variables and 1 dependent variable, the formula for finding out the multiple correlation is R1.234 will be equal to root under 1 minus R square 14 into 1 minus R square 12.3 into 1 minus R square 12.34. Here are a few examples under multiple correlation. A simple correlation coefficient between yield x1, temperature x2 and rainfall x3 are given by R12 is equal to 0.6, R13 is equal to 0.5, R23 is equal to 0.8. Find the multiple correlation R1.23. I repeat the question again. A simple correlation coefficient between yield x1, temperature x2 and rainfall x3 are given by R12 is equal to 0.6, R13 is equal to 0.5, R23 is equal to 0.8. Find the multiple correlation R1.23. Solution: R1.23 is equal to root under R12 square plus R13 square minus 2 R12 R13 R23 divide by 1 minus R square 23 equal to root under 0.6 whole square plus 0.5 whole square minus 2 into 0.6 into 0.5 into 0.8 divide by 1 minus 0.8 whole square, which is equal to root under 0.36 plus 0.25 minus 0.48 divide by 1 minus 0.64, which is equal to root under 0.13 divided by 0.36, which is equal to root under 0.361, which is equal to 0.6, is the required solution of R 1.23. The next example: the following zero order correlation coefficients are given. R12 is equal to 0.98, R13 is equal to 0.44, R23 is equal to 0.54. Calculate multiple correlation coefficient treating first variable as dependent and second and third as independent. I repeat the question again. The following zero order correlation coefficients are given. R12 is equal to 0.98, R13 is equal to 0.44, and R23 is equal to 0.54. Calculate multiple correlation coefficient treating first variable as dependent and second variable and the third variable as independent. The solution follows. R1.23 is equal to root under R12 square plus R13 square minus 2 R12 R13 R23 divided by 1 minus R23 square, which is equal to 0.98 whole square plus 0.44 whole square minus 2 into 0.98 into 0.44 into 0.54 divide by 1 minus 0.54 whole square, which is equal to root under 0.9604 plus 0.1936 minus 0.4657 divided by 1 minus 0.2916 is equal to root under 1.154 minus 0.4657 divided by 0.7084 is equal to root under 0.6883 divided by 0.7084 is equal to root under 0.9716, which is equal to 0.986, which is the required value of our 1.23.